If people are still enjoying the sunshine, it's their problem. Um, Good morning, everybody. Welcome to this session, the last session before lunchtime. I heard it was a vol au vent with French fries before lunch, so I'll promise I will make it quick. My name is Jasper Lammes. I'm a Drupal developer, and for the moment, I'm working at Drupal. Drupal is a digital experience company. I think everybody knows it here. We're also one of the sponsors, so make sure to stop at our booth. I don't know if anybody is present at the moment at our booth because I think everybody from Drupal is sitting here, so don't run away. But that's all the corporate stuff that you will get from me. The other part of the slide, that is all based or all things related for on my personal home. So if there's anything negative about it, it should only reflect on me and not on Drop Solid. They just gave me the opportunity to work on the slides. So that's that. All right. So a couple of years ago, me and my girlfriend, we bought a house. After a couple of months of painting, installing a kitchen, putting tiles against the bathroom, and so on, we moved in. What you also need to know, me and my girlfriend, we are very heavy volleyball players, meaning that we have 2 or 3 times the training in a week, and then we also spend some time in the weekend, not alone on training or playing a game, but also coaching a youth team, for example. So it's very important that we have clean clothes, clean official clothes in the weekend. You see the number 9 or the number 6 or the number 15, those are official costumes, like or yeah, the news as we say it, and they need to be clean in the weekend. There is one missing because my girlfriend, she's also a referee. It's very important that she has them. But before we go further, quick show of hands. There's only one point in this presentation that I will interact with you, and that's right now. Quick show of hands, who gives a nickname to their home appliances? For example, their tumble dryer. Yeah, I see a few people. All right, that's good. So that won't make my next slide not that weird. For example, my washing machine and my tumble dryer, I gave them nicknames like the Bubble Blitz and the Dry Heat Dynamo. Um, and they are a very important part of my household. Yeah. 1 year later, after we moved in, we also installed solar panels on our house, and that's when I became more and more interested in home automation, energy management, and so on. And that is what we are going to talk about today. I'm going to present you the idea. I'm going to present how I solve it in my understanding of the point of view. I'm going to talk what's next and then some key takeaways. All right? SPARC, that's the title of the presentation and the title of the project, is an idea on how to solve the problem that me or anybody else who is a homeowner or a resident, we are pushed away or urged to reduce energy usage from non-renewable energy sources like gas, coal, or nuclear power. But how can you do that without investing a ton of money in smart devices and an energy management system of a specific vendor? And the last part, the vendor, is very important. Don't get me wrong, I love smart devices. I have some light bulbs and switches in my home from IKEA, for example, and they work great, but they are not allowed to talk to the outside world except for fetching some updates, and I also can't access them from outside my home. That's very important, just for security purposes. Now, you have to ask yourself, would you be comfortable that your power hungry devices, like your dishwasher or your tumble dryer or your oven even, are connected to the outside world? I mean, those platforms and that software that runs on those machines, that is still created or still developed and managed by humans and companies. So therefore, they are very susceptible to bugs, errors, mistakes, policy changes even. And I don't want that. For example, in March 2022, a developer at AEG, he published the wrong software update for a particular line of microwave ovens. He was targeting steam ovens. He put in the wrong number, and now every microwave oven thought it was a steam oven. So it mentioned on the display, I am now a steam oven. Would you like me to steam your food? Even though the hardware wasn't there. So that was a big problem. And not only that, the developer also bricked the over-the-air updates. So what happens now? IAA is calling everybody who has registered a microphone. Hey, I want to come over. I want to fix it with a USB stick. That's ridiculous. I don't want that. Another thing, MIT, the big MIT department published an how-to article on how to hack your fridge. Yeah, I don't want that in my house. Huh? So in terms of acceptance criteria, the thing that I want is very simple. Given that I am a home owner, when I rise in the morning, then I want to see a notification on my phone on how to schedule my power-hungry devices. Those are dumb. Those are not smart. So that means that I can load them, put in a small tablet or some powder to make it clean, delay their execution, like I want you to start in 2 hours, 3 hours. That's something that is just locally defined on the appliance itself. And then I just go to work. But I also want I also want to ask it questions like, what is the best time for me to start the automatic cleaning process of my oven? That cleaning process, it heats the oven to 200 degrees to remove all the dirt inside of it. I also want to ask it questions like, can I run the dishwasher and the washing machine at the same time? And so on and so on. And for that, I used Drupal for any reason that everybody else would use Drupal. The API is very good. The developer experience is very good. So it's my first pick. And that's why I came up with this name for my project. It's called Solar Powered Advanced Renewable Control. Now, before we go any further, I want to make one thing clear. I am not responsible, nor can I be kept accountable for any change that might occur in your home situation as a result of what you've learned today. If you suddenly find yourself in charge of the entire household, that's purely up to you. All right, proceeding with the how. How did I make this project for me? There are 3 puzzle pieces, and we are going to start with the first one, source of the data. The source of the data is coming from my solar panels on my roof, and there is an online application called Solcast, and it has an open API. I need to register my home. I need to submit some specific details about my solar panels, like the azimuth and the angle of how they are towards the south, and they will calculate the output of my solar panels based on weather, based on irradiance, and so on and so on. The digestion of that API is done via the second logo. It's the logo of the HTTP client module, and it allows you to define an API via Gazelle service descriptions in very simple format like YAML or JSON. Don't worry, I will show some examples in a few minutes. This is their dashboard. So as you can see, there are some graphs here. I think I took this and at the end of the 2nd of March. So here you see the 3rd and the 4th March. Okay, some output, but here very sunny day, and here a bit more cloudy. And that data is being ingested by an API, and that's how it looks. So for a period of time, I have so for every 30 minutes, I have the estimate of 1.0456 kilowatts. The second half hour is at 1.139. You have the 10th and the 90th percentile. 10th means there are more clouds, and 90th percentile means there are less clouds. Gazelle service descriptions, for those of you who haven't heard of it, it's really powerful, and it allows you to define an API via YAML. So you say you set the HTTP method, you set the URI, you specify a summary just to describe what the API is all about. You set some parameters. You can say the accept type, it's for the header. You can specify the authorization, it's also for the header, and then you can say the resource ID. And if you look at the top in the URI, So you see that the resource URI is for that specific location, and it's required. So all those kind of things, you can configure them. You can also say, this is going to be my response model. It's a forecast list. And inside that object, there's a forecast property. It's an array. And every item inside that array is of also the object type. And it has some properties like the period and the PV estimate, and so on. That file is part of a module. When you run Drush Cache Rebuild, it will look like this in the admin interface. And that's it. Just one file in one module, you enable the HTTP client module, and then you get this. Now, I also said in the beginning that there is a resource ID and an authorization header. When I fill those in, then it becomes configuration. So here I have configured one instance of that HTTP client instance, and I've set an authorization, and I set a resource ID. The resource ID is generated by Solcast, the same for the API client or the API key. I can execute it, and then it will give me that response. To store the data, I've chosen InfluxDB. I don't know if anybody heard of it. I think it does. It's an open source time series database, and it's mainly used in the IoT field for storing time series data. It also contains a very powerful query language called Flux, and it allows you to do calculations and alterations of the data before it's being sent to the user. But how are we going to combine the two? How are we going to ingest the data from the HTTP client module, and how are we going to store it in InfluxDB? For that, I'm going to use the ECA module. ECA stands for Event Condition Action, and it's a rules engine. I don't want to say it's the successor of rules, but it's a very good alternative where rules left Drupal 8 somewhat behind. This one stepped up, and it's really, really powerful. At the core, there is a processor that listens to events, and based on certain conditions, it will execute an action. For the interface, there are a couple of possible options like bpmn.io. That one is the most known. You also have Camunda, which is more like, how do you say it? It's more like a program that you run on your machine itself. And then you also have the ECA Classic Modeler. One small example of an ECA model is on login, redirect the user if he's the administrator. If we go into detail, it will look a little bit like this. So the circle is an event, and the event on this one is on logging. Then we're going to validate if the current user has the admin role, and if that is applied, then we are going to redirect that person to admin/content. So the redirect on login module, you can throw it out. No need for that. You just create an ECA model, and you're done. Now we're gonna step it up a notch. This is the model that I used, or that I created, to ingest the data from the HTTP client module, from the Solcast API, and put it into InfluxDB. First thing, again, this is an event. I just define a custom event ID. It will be more clear when I show the drush command. We're gonna execute the HTTP client module for the instance that I have configured. Remember that I created one particular configuration with the authorization, the API key, and the resource ID. That's that one. That one. And remember, this was the output of that API, and I'm gonna loop over it. Looping means that there's a gateway in between, and that gateway is an OR gateway. So for example, I only have one output at the moment, but you could also extend the second one here. And for every item, I'm gonna loop over the list. And with the list, I mean the token at the top. So you see at the top, Solcast, Core 45 forecasts. That's the list. And I'm going to validate, before I go to the action of pop item, I'm going to validate if the size of that array is still bigger than 0. If it's not, then it means that I've processed everything or every item that was in that list. So for every item, we're just gonna pop the first one. We're gonna save it in a separate token called forecast item. And then we're gonna store it in the queue. That's it. And for every piece of that, we're just going to loop over it until everything is in the Drupal queue. When cron is then run, another event is broadcast called queue run or something like that. And I'm gonna fetch the task which I set up in the previous slide called Soulcast Forecast. And I'm gonna manipulate the data for every item that is in that particular task. The first one is, if you remember, the API specified the period end and the period time, so PT 30 minutes and then the period end time. But yeah, I don't know why they do that. I'm just interested in the period start. So I'm gonna subtract 30 minutes. I'm going to subtract 30 minutes from that period start and save it as period from period end, and I'm going to save it as period start. So that is what this action is doing. Then there are some alterations that I do on the PV estimate. For example, the output of the API is in kilowatts. I only want watts, so the basic value. So I'm just going to make sure that the value of the output is a float, because that's very important in InfluxDB. Once you store a value inside a specific tag, and for example, the value is an integer, and afterwards you want to put for the same timestamp a float, InfluxDB will say no. The structure of the data is integer. Now you're going to want to save a float. That's not going to happen. So I'm going to make sure that we are storing integers by making sure first that we have a float. Then I'm going to convert from kilowatts to watts by dividing it by 1,000. No, yeah, multiplication. Going to save it, and I'm going to convert it to an integer, and I'm going to. So that would mean, that for example, the 1.0456, that one is going to be converted to 1064. The same for the 1.139, it's going to be converted to 1000, what's it, 1040 or something. Then we're going to create a point in InfluxDB. A point can have different properties. For example, you can specify tags. Tags are very loosely coupled. I just say that every point has a tag of the type, and I call it forecast. There's also an API endpoint where you can get historic data. So when I would ingest that, instead of forecast, I would say history, for example. Then the fields I'm going to ingest are the PV estimate, the PV estimate 10, and the PV estimate 90. The date time, yeah, that's what I said in the beginning, is the period start. I can set the datetime format, the precision, and then the token name, which is going to be used in the next action by sending it to InfluxDB. So the point that I created in the previous action, which is stored in a token, I'm going to send that to a bucket in InfluxDB. The bucket itself is also configuration. It has a machine name. It has a retention policy in seconds. I think this one means that every data point in InfluxDB is going to be stored for like a year or something. And then this, something simple like a status and a label. That particular set of functionality that is part of the InfluxDB module. It's on Drupal.org. Take a look if you need it. And then I'm going to trigger the model, meaning that the custom event ID that I set at the beginning of the model is going to be used as an ID or as an argument to trigger this particular drush command. And if everything goes well, this is how it looks like in InfluxDB. So if you see at the dashboard from Soulcast, And this one, it looks fairly similar, so I know that in my entire model just works. Next piece of the puzzle, so we had the data, it's coming from Solcast, it's put into InfluxDB. Second part of the puzzle are allocations. So for me, this was, I think, the hardest part of the project. How am I going to know how a specific energy part or energy process of an appliance is going to fit in those graphs, those mathematical thingies? I don't know. So that was the hardest part. Let's first zoom into one particular day just to solve the problem. So where you had 3 days, I'm now just going to zoom in on the first day. So you see the PV estimate, the PV estimate 10 and the PV estimate 90. I'm going to remove those as well. I don't care about less or more clouds. I just want the average estimate as I can get. I'm gonna do the same thing in Grafana. Grafana is basically also an open source visualization tool for various databases like Influx, like MySQL, and so on. And the thing at the top, that's the Flux query that I talked about in the beginning. So basically, this graph is the same as that graph, but just in another visualization tool. And then the next thing, for me, then my, how do you say it, my penny dropped, mijn frank viel, when I looked at this one. It doesn't look like a graph anymore. It doesn't look like a mathematical problem anymore. Now it's just bars, and I want to know which bar is going to be used for an application where an application is also resembled by a specific bar. And it looks fairly similar like memory allocation, but for memory allocation, you have like 8 slots of RAM, 8 gigabytes of RAM, and you know, 8 gigabytes, I want to run a program of, I don't know, 512 megabytes, then I know, okay, it will fit into that first slot. But this is not one fixed set of slots. I have different kind of slots with a variation in height, so variation of allocation possibilities. In memory allocation, there are multiple of allocation algorithms. I just copied over 3 of them. The first one is best fit, meaning that the algorithm will look for a block. That matches the requested amount of energy as closely as possible, meaning that the remaining part of energy will be as small as possible. Worst fit is basically the opposite of best fit, and the remaining energy will be as high as possible. And then first fit, it just allocates an appliance based on whatever it can find at the first time. How do you know how much an appliance actually consumes? For me, I didn't know how much my tumble dryer was using when I set it up, or my oven, I don't know. And for that, I used the European Product Registry for Energy Labeling. In the 1st of January in 2019, manufacturers and suppliers in the European Union are obligated to register their products inside a global database. And there are a lot of categories. They have dishwashers, washing machines, even tires. I don't know how you want to compare tires, but apparently manufacturers have to register them. And in May 2020, I think a couple of years later, it was published for free access. So we as consumers, we can search for the best possible product that we want based on different kind of properties that we want to compare, like amount of water used, noise, warranty, whatsoever. But I am only interested in the things that I highlighted in red, which are the energy consumption per cycle and how the manufacturer decides what a particular cycle is. So for example, you see that for a duration of 4 hours, it will use 0.964 kilowatts per hour. They also offer a free API access. I've submitted access in, November 2023. But as you know, the European Union is not that fast, so I still haven't heard from them. I reapplied, I think last month. They said, yeah, there's a problem with your application. I fixed it, and then no answer again. So I don't know. I probably have to wait after the elections. Combining the two results in a drush command where I can say for like give me the allocation of two appliances. The A are for appliances. An appliance can run or is consuming 850 watts, and the second appliance is consuming 300 watts, and the 8 and the 4 stands for the amount of window duration that I want to use. So for example, a window duration of 15, and I want to allocate an appliance for 4 times the window duration, that means 1 hour. The same for the 8 times 15 is 2 hours. When the result of that command will look like this. This is for the best fit allocation or the best fit algorithm. And as you can see, for that appliance of 50 watts and 200 watts, the 200 watt appliance I can start at 1:15, and the 50 watt is at 3:15. Now, tables and data like this, it doesn't mean anything, but if you look at like this one, this will make it more clear. So this is best fit, meaning that the remaining part of energy here between the usage and the actual output of my solar panel will be minimized. The same for these two blocks. That's those parts. The rest of it is as small as possible as it can find. Now we also have first fit. Then you see the 50 watt appliance I can start at 8, and the 200 watt appliance I can start at 8:45, and there's a bit of overlap. So that would look like this. That is just first fit, the first thing it can find. We also have worst fit, meaning that the amount of energy will be, the remaining part of energy will be maximized, and then it looks like this. So you see three different algorithms are resulting in 3 different optimizations, and it's up to you, it's up to the user what you say, what fits my use case best. For example, when I come home in the evening, then I want my machines to be done. Then you think, okay, best fit works best, because then when I just came home at 4:30, then I know my machine are just about done, and I can, I don't know, put out the laundry and hang it up to dry. I don't know. Final piece of the puzzle, the output. In the beginning, I said I don't want a specific new app on my phone. I don't want to create that. That's stupid. I have a lot of apps. I don't want anything new just for this particular use case. I also want to see what I did the last days, or what my program proposed for me the last couple of days, or when I want to ask it questions, I want to do that in basically like a terminal. So I've opted for Discord. Discord is like Slack. I think everybody knows it, but they also have a great API. And in combination with React PHP, React PHP is basically like a loop that you start, and you define your callbacks based on certain events before you start the loop. It will be more clear in just a minute. I've created a module for that particular API. Now there is already a package. Is it on this slide? No, there is already a package that will incorporate React PHP and the API together, and I just created a Drupal module that it will incorporate that particular package, for which you can start a loop with just a drush command. And that's all it takes. So as you can see, this is the drush command, and I have created support for 2 different events. So I say when a message is created in Discord, I'm gonna dispatch a Symfony event called message create event. When Discord says it's ready, I'm gonna publish a ready event. This is just some optional timeout properties that you can give it to close the loop. and then you start it. So every time in Discord, in a particular channel, somebody types something, this event is being broadcast inside my Drupal application. And when I say events inside the Drupal application, we come back to ECA. All right? This is my module or my model to listen to specific events in Discord and how we can react to it. First one is really simple. The Discord event ready event is being broadcast, and I just log something like Discord is ready to be, or my module or my project is ready to be picking up other events. Then, when a message is received, when that particular Symfony event is being broadcasted inside my Drupal application, I can say only continue with the next action if that message from Discord starts with /drush. When that happens, I remove the drush parts from the message content. As you can see at the top, that's the token that I'm using, and I'm going to save the result of that negative drush command sort of thing, the string. I'm going to save it in the drush command token. I'm going to explode the argument. So every space inside my particular message will be used as an explosion argument to create an array of it. I'm going to execute that command, and I'm going to save the output in another token called drush output. And for that, I'm using the process component from Symfony. It's nothing new. It already exists, so good for me. That's the command. That's the action that I am using to run a specific drush command. Then I'm going to truncate the output. Why is that truncation necessary? The API of Discord only allows 2,000 characters to be sent over the API, so I can't send the entire drush output. I need to truncate it. And I also strip three characters of it because of the ellipsis that is being added at the end. So the command was successful. That's one condition. And then I use the reply method to send the drush output as a reply to that message that initially triggered this particular model. When an error occurred, that's also possible. I trim more of the message because I'm going to prefix the error message with error. So as you can see, the content of the message is going to be error, space, and then the drush output, and I'm going to send it as a reply to that same channel and that same message from which it originated. And then it will look like this. So in drush, in my channel, I can say drush st, so the status command, and then you will see something like this. I can also run drush bar foo, foo bar or drush bar foo, it isn't recognized, so it says error, comment bar is not defined, and so on and so on. I can also say drush st help to get the descriptive information of the status command, and I can also, for example, say drush give me the watchdog tables or the watchdog entries, and you will see it's not complete, so at the end there are 3 points to say, okay, more output can be fetched if you run that command on your local Drupal environment. Combining those 3 puzzle pieces, so first we have Soulcast, we put it inside Drupal, from Drupal to InfluxDB. If we want to allocate the influx data and the April data, like the appliance usage, then we're going to send it to Discord. It will look like this. So in drush or in Discord, I can say drush allocate me an appliance for the best fit algorithm, and my Drupal instance will just reply with it. And I think that's for first fit. Yeah, so this is what I actually wanted. I can tell my application via a specific or via an existing application. I can just chat with it. There's no AI behind it. I can just chat with it, and it will send me the things that I want to know. And I think that's pretty cool. And that's actually what I wanted. All right. Next, because this was just the MVP part, or yeah, that's just something that now works. What else is in the pipeline? Ingest data from another provider. I've used Soulcast at first. There's another one. This one is situated in Europe. I think the other one is in Australia. But I want to ingest as much data as possible in InfluxDB. And when I request data for the allocation algorithm, it will just calculate the mean or the average part for every data point that I requested, from whatever or from wherever database it's coming from. Next thing I want to do is use this particular product or this particular API more. Now I'm just saying that in the drush command, give me 500 watts for that amount of window duration and so on. So I need to look that up manually inside the database. Once I have access to their API, I can use the entity API to just create a data model inside Drupal and say, okay, my appliance, my dishwasher, I call it Bubble Blitz. It hasn't, that's the particular machine on April. So there's an API call that I can use to fetch that particular usage without looking it up manually. Allocation templates. This is particularly coming in handy when I want to say, okay, create a template for the washing machine and the tumble dryer. They cannot be run simultaneously. That's stupid. They need to run after one another, and there also needs to be a gap of like, I don't know, 15, 30 minutes that I have time to put the clothes from one machine to the other. That particular template I can then use to schedule or allocate that particular usage for that particular template. Or, for example, I need to run the dishwasher 3 times a week. That's a template. Allocate me the necessary time points and send it to me via a message. The other thing that I can do, but that's perhaps more long-term, is kick out the April integration and use Shelly. Shelly is a manufacturer of smart switches, and it enables me to fetch the usage of my appliance locally. It's like a small, I don't have it with me anymore, but it's like a small socket that you put between your socket in the wall and your machine, and it will register those usages and send it to your local InfluxDB. That would mean that I can calculate or allocate, instead of an appliance, I can allocate a program. Because, for example, I know my, my program for my regular washing machine, it takes like 3 hours, but that's for mixed colors. I also have a program for black clothes, and for black clothes it's more shorter. It's like 1 hour and a half. So that would mean that the amount of time or the amount of energy that I would need to use is fairly different. And with Shelly, I can calculate that, or I can capture those energy usages and put them in a local database instead of using the April one. April is too generic, I think. The next thing, and this is probably the most sophisticated one that I will need to do, is switch from absolute values to something like how much would a certain appliance, how much would it cost me to run? For example, in the winter months, it could be that for, I don't know, 3 weeks, there is not that much sunshine, so my solar panels aren't providing me any power. But I still want to allocate some space based on the price it will cost me for that particular appliance for that particular time. And I can use that, I can do that because there is the NSOE database, which is also a European product, but for electricity prices. It has an open API. I already have an account, so that's good. It didn't take me that long. So that would mean that I can also ingest data from, what's it, 3 months, 4 months, what the prices are going to be. I can ingest that in my InfluxDB database, and based on the price, instead of the solar output, I can calculate a price, and then I can see, okay, what's the least amount of euros that I need to spend based on first price and second possible solar output to run my appliances. Final part, key takeaways. What should you remember from this session? If you have an API and you think you want to use it inside your Drupal application, don't forget to use the HTTP client module. If you want to store or work with time-related data, use InfluxDB. and Grafana, of course. If you want to create workflows like this one, please use ECA. It's not only good for technical workflows, but also for content moderation. Like if node 1 is edited, send a mail to that particular content or contributor or that particular user on your site. So again, ECA, event condition action. Jürgen Haas, I don't know if anybody knows him. He's very active on Slack, and he also, I think, during the last Dries note, he pledged that he will make sure that ECA is part of Starshots in the near future. And that's it. Thank you for your attention, and if you have questions, please let me know. I need to throw something. Yeah.
Couple of questions. So the first one is, how did your girlfriend react when you explained she had to use drush commands to know when she could use the...
She doesn't know about it. The only thing that she sees me doing is fumbling around with the machine in the morning, and for her, it's okay that if I arrive at home in the evening, everything is done. She doesn't care. She's just happy that her clothes are done and proper.
Right. And the second question I have is, so you don't want to open it up, but you did open it up by making it open via Discord.
Mhm.
Isn't that the same thing? Like, how is it now you're putting your faith in Discord not being hacked and not having your own system like with Ophelia or Authentic or something to protect the UI?
That's a good question. And I think, yeah, of course, the Drush thing or the Drush integration, that's too open. Of course, I need to limit it. For example, I can say in a model only execute the allocation Drush command. That's something I can do. I didn't think of it now, or I didn't do that right now because I just wanted to make it a proof of concept. So yeah, of course, it's a big big security gap that I need to close. On the other hand, the project itself, it's only running on my local machine inside some containers. Yeah, I still want to see if somebody can break out of a container.
Don't think it's going to be that interesting for people to hack.
No, indeed.
And the last question is, when maybe you could go back to the slides for the allocation with the different algorithms. I think it was the last one, the worst fit or first fit, that showed, yeah, it's a while back. Like the graph not the graph, the one before that. Yeah, so the one before here. So if you look, it's the table actually, because this doesn't show it. Could you show one of the tables?
Oh, the table, yeah.
So there you can see, for example, you can start your machine from 200 watts at 8:45, but then you need to stop it for 15 minutes so it doesn't run it continuously. So you need 8 slots of 200, but there's an interruption for the 4th slot of 50.
Wait, you start it here at 8:45 and it continues at 9 o'clock, 9:15, 9:30.
Yeah, but that means that you start it and you need to stop it for your 50. So if you would have like sun and your sun usage or
No. It's on top. They top off. You start both at the same time. So no, not at the same time. You start it here, the 51 you started here, and it's allowed based on the allocation. It's allowed to run until here. So that's the entire hour, 8:15, 8:30, 8:45, 9:15.
Oh,
that's where it ends.
The same. I'm sorry, I missaw the slots. I thought it was like you had 3 slots of 50 minutes of 50, then 1 slot of 200, and then you had another slot of 50. But I didn't see the timestamp. Sorry.
No problem. That means that this is not clear enough.
Yeah. Good luck with your girlfriend getting.
Yeah, she doesn't need to read it. I just need to make sense of it. Yeah.
Anybody else? Right. I'm gonna try. Okay.
Yeah, I don't know if it works or not but in France you can sell the energy. I don't know in Belgium how it works, but the solar energy that you produce, you can sell it to the. So can you make it decide? So for example, when is the best time to sell the energy to the provider? Because if you don't use the machine and you know that it's better to launch, for example, the machine now because the energy is cheaper, and you can sell it after because you don't use it anymore.
Yeah, indeed. That's something that some of the more bigger companies are providing in Belgium as well. So you have like an injection tariff, I think it's called in Belgium. And I think it's based on your contract. So it's not dynamic. I think it's one particular price. So that's something indeed that we could incorporate in this allocation program as well. So based on that particular injection tariff, I could say, okay, the best fit is not where the rest energy is minimized, but I can also say, yeah, only send it or only start a program when I can get as much return in value as possible as well. Yeah. Anybody else? If not, we can go for French fries.
Just one question. How much time did it take to make all this? Like, just like curious.
A lot more than my girlfriend would have hoped, because those are evenings that I'm just spending at my laptop and not with her. But I think I started with it in Q4 last year, and then when I had time, when I'm not at the volleyball court or when I'm not spending time with her, I was fiddling around with this one. So yeah, it's less than a year or something, but yeah, little bits and pieces that puzzle me and that I want to solve. So yeah, sometimes it's more time, sometimes it's less time, depends.
Okay, thank you.
French fries, yes.